And hello everyone, welcome back to your next tutorial on creating a file sharing website. So first of all, we want to be able to encrypt strings at some point, because when you work with a website, you generally want some security. Whilst we are not going to do a lot of secure things here, we're mainly just going to encrypt the password here and there. You should be encrypting as much data as possible that could be sensitive information. So let's create a function that can encrypt. So here we can say define encrypt string, and this will take in the string we want to encrypt. I'm putting an underscore here so it doesn't actually think I'm talking about the string type. And this will be of type string, and it will return us another string. This would be the encrypted string. And here we can just say this will hash the string. Now, there are a lot of ways to hash/encrypt a string. We are going to use SHA-256, which is currently one of the more popular ways to do it. Now, you get two types of hashes. You get one that once you encrypt, you cannot decrypt. So it's a permanent encrypt. And then you have a salt for that, where if you want to test, let's say, a password with another password, see if they match, then you have to encrypt the password you want to test against already encrypted password. And you need to have the right salt, otherwise it will not give you the same value. So let's actually create a little salt. First, I would like to import two new modules, hashlib and binascii. If you get an import error, you might have to install these, but I do think they come with Python. But you might have to install them if they don't, which is a pip install. Let's create a salt, and the salt can be equal to hashlib.sha256. And there are lots of ways you can create encryption/hashes. All you need to do is just find your way of doing it. This is just one way, and it's an easy way, and that's why I'm using it. Then you can go os.urandom, and we can say 60. To give you an idea of what that means, if we go here and say Python import os.urandom 60, then you get a byte of this. So that is what we're passing in here. We can then change that and convert it into a hexaddigit. And we just say .encode, and you pass in into ASCII. Now ASCII is what we use. So this U here, that's an ASCII value basically. Now ASCII is more numbers, and they kind of code together. So you have your numbers, which would be like 96, which I think translates to a lowercase a. But to give you an idea, if we were to just import hashlib, and let's actually copy and paste this to see what we get. So this is what we get as our salt. And every time we run this, we'll actually get a different salt. Generally, you do not want to change the salt. But the way we encode it, it doesn't matter too much. But generally, you do not want this salt to change. So generally, as a salt, you can just put a piece of text here, a secret key in a sense. We're going to go str hash, so this will be the string version of the hash, is equal to hashlib dot pb kdf2hmac. Now this is a good way you can use to especially encrypt things such as passwords. Then we just pass in SHA-512, there's another encryption method, str.encode into UTF-8, so what we understand. This is kind of like UTF-8 based characters. Then say salt, and if you're having trouble following along with this, and then just 100,000. So if you're having trouble following along with this, then don't worry too much. This encryption isn't the big deal about this course. So if you have trouble with this encryption part, don't worry. It's only a one-time thing for now, and then you don't have to worry about it again. Now here, we're saying it should go through this salt 100,000 times. Now, the more this is, the longer this will take to encrypt. So to give you an example, if we were to go to Python again, import os #lib, and let's also import bin ASCII. There we go. And let's get this salt in here again. Paste that so we can get a salt. Salt is now this. And then we can just go _str, and that could be a piece of text such as hello world. And now if we were to go like this, paste it, and this should be string underscore, not underscore string. And now if we were to do it, we'll get something along the lines of this. Now, of course, if we were to add, let's say, a few extra zeros here, you'll notice it's taking a lot longer and also taking a lot more resources to do it. So the more you make this, the more difficult it would be to brute force an encryption. So when someone tries to constantly try and see if a password works. So the longer this takes, the longer it will take to confirm if the password is the correct password, which has a downside and an upside. On the upside, if it takes longer, it means a hacker will have more trouble trying to figure out if this is the correct password, because they'll have to wait longer between requests to see if that is the correct password for this account. The downside is the longer the user has to wait to just be able to log in, the less the user would want to log in. Now this is going to take a while, so I'm just going to stop it right here. There you can go str hash, and you can make that equal to bin ASCII dot hexlify str underscore hash. So you're passing this into itself here to get the hexified value, and return salt plus str hash dot decode. Now if we were to take a look here and maybe copy and paste this into here, and then run encrypt string, and then type, let's say, hello world, we'll get this. So this right here, that's what we are going to be seeing. So this is how a password will basically look. And every time we run it, you can see it's something different here. Next up, let's start working on our database. So where we'll be storing the users and their information. So here we can create a new folder called databases. New file, init.py. Another new file, and this can be db.py. Then here we can say from Flask SQL Alchemy. You might have to install this if you don't have it. Import SQL Alchemy. db is equal to SQL Alchemy. So this will initialize a database for us, so we can create an SQL database. Now let's create a users database. So here we can just say users underscore db, or just users, whichever floats your boat. From .db import db. So we're importing this right here. We're importing this db. And then we can create a class users, and this will be the database name or the table name. db.model. So we're creating a new database model. And here we can create a basic way of how our database should be structured. So we want an ID, which will be equal to a db.column. We can then specify db.integer, because we want a number. So this ID will be a number type. I'm not going to go too deep into databases and all of those things. I do have an entire SQL course if you want to know more. A database is just basically a way to store data. And here we can just say what it should be storing. A primary key, and this primary key can just be true. This means this will be the key that uniquely identifies each row inside of a table in the database. So if we had an Excel sheet, so here we go. This is kind of like a database. So here we have a name, or in this case, you can say ID. Then we can say name and password. Now each user will have a unique ID. So here you can say 1, 2, 3, 4. This is the user's unique ID to identify them. No one else will have the same ID. So there will never be another 4 or another 3. These will never happen. That is why it's the primary key. It's uniquely used to identify a user. Here we can have Mike, and then their password, Jack, and then their password, maybe another Mike, because people could have the same name, but we know this isn't the same Mike because it has a different ID. So they have a different ID here. And here we could say Sally and her password. There we go. So this is how basic a database is. It's literally just this. Now here we can create a username field. So almost like that name field we have. db.column. And we can say db.string. And this piece of text is only allowed to be up until 50 characters in length. And it may not be an empty value. So almost like Python null, none I mean. So this is almost the same as null. So null and none here are basically the same. If we say it's not nullable, so here we're saying it's not nullable, it means that field is not allowed to be empty. We then also have a password. We just go db.column, db.text. This means it can be as long as it needs to be. There's no limit. Nullable is equal to false, so they do need a password. They cannot log in without a password, basically. Mod underscore, and this will be to tell if they are a mod. So you can have like a moderator and an admin, where a moderator has almost the same access as an admin. However, admins could remove other moderators, as an example, while one moderator cannot remove another moderator. You don't have to do so complex. I just like the complexity. Create another column. This can be db.integer. We are saying integer here because SQLite, I believe, do not have booleans. So we need to say integer, where 0 would mean false and any other value would be true. We can then go nullable is equal to false, and its default value will be 0. So by default, they are not a moderator. Admin underscore, so if they're an admin, will be the same concept, but this time it's just if they're an admin. Date accessed is equal to db column and then db.date. So it's going to store a date for us, and then nullable is equal to false. Now this date accessed would be the last time the user accessed the website. The reason this is here is because in my previous program, when I actually launched this website for me and my friends to use, what happened was I wanted to delete users that hasn't been online for maybe a year or two. Because let's say there are 100 people on the website. It can be pretty taxing to store all of that information because it's not free. You have to pay to store. So I delete what I don't need. And let's say there's 1,000 people on the website, but only 90 people has visited the website in this last year. Then I delete all of the 900 other people that were not on the website. Note, this is never, ever, ever a good idea. Don't ever actually do that unless it's specifically planned for your website. And then you should very well notify your users about it. I did it because I needed to save money, and it was anyways just for me and my friends. However, you should never actually just delete a user's account. that is almost never a good idea. Or at least send them an email to tell them you will be removing their account if they do not reply. Or if they do not log in again or something like that. But don't ever actually do this. I only did it because I thought that was a good move to go to save a little bit of money. Cool. Now let's go to init.py. And here we can just say .databases.db import db. And now this will import the database for us, which we can now initialize. So in this test environment here, we can say app.config, and here we can specify SQL Alchemy database URI, and that is equal to SQLite //tmp/users.db. This means that we will store the user's data inside of an SQLite database. Why SQLite, you may ask? Because SQLite is super easy to use and it is super simple to set up. And then this 2 slashes here means our current folder, so this current directory, put it inside of a TMP folder, and then users.db is the file name. So let's go here and say new folder TMP, and I'm calling it TMP because you don't want to use an SQLite database on a production website. So if you have an actual website, don't do this. You rather use MySQL or PostgreSQL just because it will give you the option of longevity, so you don't have to worry too much about upgrading later and migrating all of your data from SQLite to MySQL, for example. Then here we could go app.config SQL Alchemy track modifications, and then you set that to false, so it doesn't track the modifications you're making in the database, just to save a bit of resources. And then db.init app, and now we'll initialize that database for us. Now let's try to run this. Now I'm getting an error here saying no module named Flask SQL Alchemy. In this case, I can just then go pip install and Flask SQL Alchemy. Now if I were to run this, then now it says we got another error, and my bad, these should be 3 slashes to specify this directory, not 2. If you say 2, it's going to go to a directory such as the home netc documents. Like, it doesn't quite work out. So 3 forward slashes, not 2. Now if we run it, it will start up, and we don't have our database here yet, but if it starts up, we are doing good. Okay, so we have connected our SQL database. And that is all for today. We just wanted to create our database, and then we'll get into actually using it later. Thank you all for watching. I hope you all enjoyed, and I will see you all again in the next Flask tutorial.